Hey peeps, it's Sophie from Disrupt Tutoring, and as always, such a pleasure to join you. Today we're going to deal with the grade 11 2017 physical science paper, and this question is on gravitation. So, some important constants over here. The first one is the gravitational constant, and the second is the radius of Earth, so just keep those in mind during this question. So, the first question let's read the question first. So, the acceleration due to gravity on planet X is 2.7 meters per second squared. The radius of this planet is 1/3 of the radius of Earth. Okay, so that's going to come in handy later. Okay, so the first question though is a theory question, and it asks, explain the difference between weight and mass. So it's important to note that weight is a measure of force. So weight is a force. And that is measured in newtons. And weight is the force that the Earth exerts onto an object. But mass is the amount of matter that makes up an object. And that's measured in kilograms. So it's important to note that mass stays constant on each planet, but weight changes as a result of this constant g, which is the gravitational acceleration on each planet. Okay. So now to make space for the next one, let me just erase this part. Okay, so 5.2 says calculate the mass on planet X. So we're given a few pieces of information about planet X. We're given that the fact that the radius is 1/3 of the radius of Earth, which we know, and the acceleration due to gravity, or g, on planet X is 2.7 meters per second squared. So let's get started. So we know the formula for gravitation is the gravitational acceleration is equal to Newton's gravitational constant times the mass of the planet that you're on over the radius of the planet squared. So in this case, we want everything of planet X. So we want the g of planet X is equal to the gravitational constant, which stays constant, times the mass of planet X over the radius of planet X squared. Okay, and we want the mass at the end of it, so I'm just going to solve for mass, and that gives us m of x is equal to g of x times r of x squared over g. Okay, now if we just sub everything in, we get the mass of planet X is equal to 2.7, which is given. The radius of planet X is given as 1/3 times the radius of Earth, which is 6.38 times 10 to the 6 meters. And then that all is squared. And then that's over g, which is 6.67 times 10 to the minus 11. Okay, cool. And then if you put that all in your equation, then in your calculator, that gives you a mass of planet X is equal to 1.83 times 10 to the 23 kilograms. Okay, so that is the mass of planet X. And then it asks us to calculate a factor by which the weight of an object on planet X will differ from the weight of the same object on planet Earth. And the only thing that influences weight of objects on different planets is that gravitational acceleration, that g. That is the only thing that influences them. So if we move on to 5.3 over here, So a ratio of G will calculate the ratio of the weights on each planet. So what we can say is that we know what G is on Earth, and that is 9.8. And we know what G is on planet X, and that's 2.7. So if we divide those, then we get an answer of 3.63, which is the factor by which, you can compare things on planet X to Earth. So that means that things on planet X are 3.6 times smaller in weight than on Earth. So if I have a 100 kilogram object, it's still going to be 100 kilograms on planet X, but on Earth it's going to have a weight of 980 newtons, and on planet X it's going to have a weight of 270 newtons. So this is the factor by which things are smaller on planet X. Okay, so that's all we need for question 5. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. And be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us a question and we'll respond with a personalized video just for you. Until next time, stay epic.